Very interestingly, if you see x cubed minus 1, or for that matter minus a cubed, or 1x minus a, and you want to answer x tends to a. So you have the opportunity to put here a cube minus a cube gets 0. In denominator you put a minus a 0, you are getting 0 1 0, right? Very interesting fact in polynomial is you can consider it as that a is the zeros of this polynomial as well as this polynomial. Therefore, the both of them has a factor in x minus a. So if you divide it, x cube minus a cube by x minus a, you will get x square. Just get the momentum, minus a into x square minus ax square. Then you have the responsibility of subtracting things out. Then you have ax square minus a cube. Then you have this a for the first time with you in the quotient. And what happens is you get this, and when this a reacts with this a, it makes two a's. And in order to satisfy two a's now, you need another a this time, but a lesser x. You need another a, but a lesser x, right? So it's a squared x minus a cube, and you get 0. Definitely you will be having the remainder as 0, because we have discussed it earlier that both have the factors in x minus a. So you see the responsibility like 2, 1, x equals 0, a does not have a power, a power 1, a power 2. Alright? Had the things been x raised to the power 4 minus a raised to the power 4, I would be doing कि x में क्या multiply करें x raised to the power 4, I would be saying x cube. This a would be accompanying x cube in this. So you get ax cube. Now you give it x but a lesser x. You give a but a lesser x. This a gets happy as he gets another a. So now you need two a's here. So you will be giving it two a's but a lesser x minus a cube x. Again you have now three a's. Now you have three a's, right? So you will be giving him 3 a's now, but a lesser x minus a. Yet it has to end somewhere, right? It has to end somewhere, because we know that x minus a is a factor, right? So if you carefully analyze, x cube minus a cube, we had the result as x square, ax, a square. X raised to 4 minus a raised to 4, 1x minus a, you got the result x cube. A for the first time, but a lesser x. A for the second time, but a lesser x. A for the third time, but no x. So if you had x raised to 5 minus a raised to 5, 1x minus a, you will be getting x raised to 4 for the first time, then first a with a lesser x, with 2 a's with a lesser x, with 3 a's with a lesser x, with 4 a's with no x. Right? So I can say that when I had a power 3, I started with a lesser x because I was trying to divide it, right? So I already had an x in the divisor, so I need a lesser x. So I get 2, 1, x equals 0, 3, 2, 1, x equals 0, 4, 3, 2, 1, x equals 0. With 3 I started with 2, with 4 I started with 3, with 5 I started with 4. And while going throughout the end, I started gaining a's and losing x, right? So I can say that if I have x to the power n minus a to the power n upon x minus a, I will be getting x to the power n minus 1 plus a for the first time with the lesser x, a for the second time with the lesser x, a for the third time with the lesser x, and goes till the time I don't get x altogether. But I will be finding on this, right? So, if I have something of this sort as my function, and x tends to a, So what I would be doing? If I put a here, right here, I would be getting 0 upon 0. That would not be an ideal way to proceed, right? So what I would do, I would divide it. And now, since I don't have anything in the bloody denominator, I have the opportunity to put x as a. So I would be getting a to the power n minus 1 plus a to the power 1 into a to the power n minus 2, which eventually makes it n a to the power n minus 1. A to the power 2, a to the power n minus 3, which eventually makes a to the power n minus 1. A to the power 3, and a to the power n minus 4 eventually makes n minus 1. And so I do have n terms here. So the answer is n a to the power n minus 1. Alright? So this is a very beautiful result which we have just concluded.